Hello everybody. In this video we're going to learn all about files. So we'll learn how you can create a file, how you can create a folder, how you can iterate through a folder, how you can load data from a file, how you can save data to a file. And we'll learn how to do that from within your NumPy code. And this will involve a package called Pathlib, which is part of the standard library. So to motivate this, you recall our steps of a simulation. Now, often the iteration is going to be the most computationally expensive step. It's going to take the most time. It could take half an hour, it could take an hour, it could take days. So usually we don't want to have to run through that whenever we want to change the analysis or whenever we want to tweak the plots. So we will instead do this. We will, once we finish the iteration, we write the results to a file, and then in a separate script, in a separate notebook, we can start by reading from those files and then doing the analysis. That'll save us a lot of time. To begin, we're going to establish a little terminology. So these are very simple terms. They're things that you already know, but sometimes they have different names in different operating systems. So I thought I would just lay the groundwork here. So first of all, if you've worked ever with a computer, you know that you have files and that you can locate those files within your file system. Let's say you have this file main. That file is in a folder or a directory called My Project. So files are also sometimes called documents, but we're going to try to stick to the word file. And then a folder is also called a directory, and we're going to try to stick to the word directory. The way you can visualize this is that you have your file system in your computer, and then there are a bunch of other peripherals. And all of these are vying for time with the CPU. That's how they get any work done. And all of that is being coordinated by the operating system. Now you have a very special program on your computer, and it's called the shell, also known as the terminal. And this is a program that allows you to interact via the keyboard with the operating system. So in Windows, we have the PowerShell. In Mac and Linux, we have what's known as the terminal. Any file or directory on your system will have a path. And that is the address that we use to locate that file or directory within the file system. Now that path can be expressed in absolute terms, that is with respect to the root of the file system, or in relative terms, that is with respect to the shell's current working directory. So what is this? What is the current working directory? Well, whenever you have a shell, it's going to refer or it's going to reside within or be on some folder in your file system. I like to think of it this way. So you have the shell and it's pointing to some folder. And you can move it around. So you can change the current working directory of the shell. Now, what if we wanted to address this file, main.py? Then if we want to write down its absolute path, then like any absolute path, you start with the root folder. And in Linux or in Mac, that is going to be a slash. And then comes the first folder, home, and then within that we're in Gomez, and then within that we're in code, and within that we are in My Project, and inside My Project you find main.py. Okay, so that's the absolute path for the file main.py. Now, if you're on a Windows machine, then this root folder would be called C2 dots and then backslash. That would be the root folder. So that presents a problem because we want to be able to write code that is operating system agnostic. So it can construct these absolute paths and do it correctly no matter what operating system you're on. So that's what Pathlib is going to give us. Now, finally, the relative path of main.py, well, because the shell is pointing at code, then the relative path with respect to that shell is just the last part, myproject.main.py. All right, we can now start talking about Pathlib. All right, we can now start talking about Pathlib. So Pathlib is a package that comes with the standard library. So you get it with Python out of the box. And we're only interested really in one object from Pathlib, and that is the capital P path. So when we import Pathlib, we're going to say from Pathlib import path. Now, what is a path? Well, a path is a very abstract representation of a file or a directory. So you can use it to address either one of those. So let's use path to get first the current working directory of this notepad. So we say path.cwd. That gets us the current working directory. And that tells us that the shell that is running this notebook is running on home/Jovian. Now this is in Jupyter Lab. That's something internal to Jupyter Lab that I don't control or know very much about. On the bottom here, on the other hand, we have a terminal that is running on my laptop computer. And so let's do the same thing there. I import path, and then I say current working directory. And okay, this path, this shell, and this interactive session of Python is running on home/Gomez. Okay, very good. So next, let's try to create a path object that refers to this file, main.py. And as you remember, that file is located at home Gomez code my project main. So this first part, home/Gomez, apart from being the current working directory, it's a very special directory because it's called the home directory. That's the one that the operating system has designated for you to put all of your files. So it's recommended that you do so because Pathlib can give you your home directory. You say path.home, and in this case, it says home/Gomez. That's my home directory. So now next what we have to do, so since we have the home directory, we need to get drilled down into code and then my project and finally main. And so to go down this file structure, the tree, in Pathlib, you use a very nifty little syntax that is, you just use a slash. And then I'm going to go slash, I'm going to go into code. So I say that as a string. And then from there, I'm going to go into my project. That's a string. And then into main.py. Now, this is a slash. It doesn't matter if you're on Windows, on Unix, whatever. If you're doing this within Python, it's always going to be a slash. And the nice thing, and I'm going to save this to a some variable. So I'm going to call this main file. Okay, so main file is a path object that points at this file. Now, even though it shows up here with slashes, this would work for any operating system. If you're on Windows, when you say path.home, it's going to give you your appropriate home directory that is going to have C2 dots, backslash, and then your username. And then if you have the same folder structure code, my project main, then this is all going to work out correctly. We've seen how we can go down in the file structure. How do we go back up? So let's say we have main. We want to get the folder that contains it. In that case, if I have main file, I can use the parent attribute of that object. And so I get the path object that points to my project folder. And if I wanted to go one step further up, if I wanted to go to the code folder, I could do the parent of the parent. Okay, that gives me the code folder. Or one more, I could do the parent of the parent of the parent and get my home folder. But I can also do this a little bit more succinctly. If I say parents, that's going to return some sort of a list of the parents. And then the first entry of parents will be the one directly above. And then the second will be 2 levels above, and so forth, all the way till I get to the root folder. What useful methods do we have for paths? Well, there are quite a few. So we have methods that we can use to inspect a file or directory, to create a file or directory, and to iterate through a file or directory. So up on top here, I have an interactive session. I've imported the path. I've defined project dir that is pointing to my project, and main file that is pointing to main.py. So the first thing that we can do is ask whether the path exists. Now that's a little counterintuitive, but let's see. Does main file exist? Yes. Does project dir exist? Yes, they obviously exist, but I can make a path object that points to something that doesn't exist. So for example, I could say main file 2 is pointing to main file 2, and main file 2 clearly does not exist. So if I asked if main file 2 exists, that's false. Now the reason I do that is now I can go ahead and create main file 2, and we'll do that in a second. So secondly, I might want to know whether a path is a file or a directory, and then I can use these methods. So is main file, is it a file? Yes. Is it a directory? No. On the other hand, project directory, is it a file? Yes. No. Is it a directory? Yes. And how about main file 2? Is it a directory? No. Is it a file? Also no, because it doesn't exist yet. Okay. Now we can get the name and the suffix. So the name is the very last part of the path. So if I look at main file, the very last part of the path is this, main.py. So I can get that just by saying mainfile.name. And then the suffix is the same thing as the extension. It's just .py. If I ask for its suffix. What would happen if I asked for, let's say, the project directory, its name is my project, and what is its suffix? It doesn't have a suffix because it's a directory. Now we can go ahead and try creating things. So if the thing, you have a path object to something that doesn't exist. It's not yet a file or a directory. So you have to specify whether you want to create it as a file or as a directory. If you're going to create it as a file, you use path.touch. If you're going to create it as a directory, you use mkdir. So let's do that. So main file, oops, if I say here main file 2 and I say touch, that's going to create an empty file here called main2.py. If I said main file.mkdir, what's going to happen? Well, let's just just in case, let's delete that main file 2 there. If I did this, this fails because this could not be a directory because it has a suffix. So I would have to create main file 2. Let's go back up here, main file 2, and create it without a suffix. And then I could say main file 2.mkdir, and that will work just fine, and it will create a directory for me. Finally, let's see how we can iterate through a directory using path.iterdir. So I'm going back to Jupyter Lab here, and I have created the same folder structure that I had on my local computer, where I had code/my project within the home folder, and then in that I had main.py. And I have defined here the same as I had before, project dir pointing to my dir, and main file pointing to main.py. So also I have a bunch of text files, and let's say I want to read those text files and process them somehow. But I also have a PDF file and I have a subfolder there. Okay, so how do we do this? So first, this is going to be with the for loop. So I say for item in projectdir.iterdir. So iterdir is going to return a sequence of the items that are contained within projectdir. All of these items. So let's just print those out, see what happens. Okay, we see that we have all of the text files. We have our subfolder here. Here we have another subfolder that's hidden, so we don't see it in this listing. Okay, so first of all, we want to ignore the folders. So how can we do that? Well, we can ask whether an item is a directory. So if this item is a directory, then we want to skip it. Let's just continue on to the next one. Otherwise, we're still going to print it. Okay, so now we have everything except for the directories, but we still have these two files that are not ones that we're interested in. So how can we skip these? Well, let's look at their suffix. If the suffix is not text, then we'll skip it. So if the item, its suffix, is not equal to .txt, then again, continue. Okay, so now we have filtered everything out except for what we're interested in. And the next thing would be down here to now load this file and process it in whatever way we want. And that's going to be the topic of the next video. That's going to be on reading and writing text files with data.